Homework 25, question 4. A ball of mass 0.3 kilograms is released from rest at a point 2 meters above horizontal ground. Falls freely, strikes the ground, rebounds vertically, rises to a maximum height of 1.5 meters above the ground, and falls back down again, modelled as a particle. I've drawn a diagram here, so that I'm not drawing lines that completely overlap themselves. I've added a horizontal element to my graph, but it is in fact just dropping vertically up and down. The mass of the ball, 0.3 kilograms, isn't used in this question. It's a modified question from an old paper, and we've taken that section out. What we are asked to do is find the speed of the ball at the instant before it strikes the ground for the first time. So, see that? We know the distance that it is travelling is 2 meters per second. Sorry, is 2 meters. We know that it is starting from rest at a speed of 0. The velocity is what we're trying to find. The acceleration is 9.8. And for the moment, we don't care about the time. Our equation is v squared equals u squared plus 2as. So if I plug that information in, v squared is equal to 0 squared plus 2 times 9.8 times 2. V squared is equal to 39.2. So v is equal to root 39.2, which is 6.26 meters per second to 2 decimal places. In part B, we're asked to find the speed of the ball the instant after it rebounds from the ground for the first time. So it doesn't just rebound with the same velocity that it hit the ground with, it's going to lose a little bit of velocity due to the impact on the ground, and this gives us a new problem to find. Now I'm going to keep down as my positive direction, and so it is going to travel negative 1.5 meters. U is what we're trying to find, and I'm expecting that to be negative with a positive direction going down. V is equal to 0 because we know it's going to travel 1.5 meters until it reaches the top. That's velocity 0. If I've got downwards positive, I've got an acceleration of 9.8, and t is equal to nothing. I could swap all the signs over for these problems, but I'm looking for a negative answer now for u, though I am asked to then find the speed, which will make my answer positive. I'm once again using v squared equals u squared plus 2as. If I plug the values in, 0 is equal to u squared plus 2 times 9.8 times minus 1.5. Rearrange that to get u squared is equal to 29.4. And u is equal to the square root of 29.4. But I want the negative value, which gives me minus 5.42. to 2 decimal places. However, we're off for speed, so I can ignore that negative and get 5.42 meters per second. In part C, we're asked to draw a velocity time graph for the motion of the ball from the instant it is released until it strikes the ground for the second time. This is a velocity time graph, not a speed time graph, which means we can have negative values for the velocity. I've drawn the graph already, we just need to fill in the values. It starts at rest and it travels up to that first velocity that we found in part A, the 6.26. At that instant, it suddenly starts travelling in the opposite direction, which means it's going to have a negative velocity, and that is the value that we found in part B, the minus 5.42. It doesn't decelerate, slow down, and then start up again like it does when it reaches the peak when it's travelling upwards. This is going to instantly transcend from a positive velocity to a negative velocity. However, this second part, where it goes up and then falls back down again without air resistance, is going to be completely symmetrical. So it's going to travel up to its maximum height at 1.5 meters, meter 0, and then it's going to carry on accelerating downwards until it reaches a positive velocity of 5.42. I haven't worked out any times yet, but I'm going to write those down. I have a value t1 for this part here, and then due to symmetry, each of these parts are equal to t2 here. And I'm just going to label this part t for the final time. In part D, I'm asked to find the time between the release of the ball and when it hits the ground for the second time. So I don't know the times of each of the individual parts, but I do know the areas of each of these parts of the graph, because area represents distance on a velocity time graph. So I know that this first triangle has an area of 2, and so that tells me that half times my velocity of 6.26, although I'm going to use the square root version of root 39.2, times t1 is equal to 2. If I rearrange that, that tells me that t1 is equal to 4 over root 39.2. Similarly, for this second triangle, I know that the area is 1.5 meters, and so half times my height of minus 5.42, but I'm going to use the square root of 29.4 times t2, that's equal to 1.5. Gives me a rearrangement that t2 is equal to 3 over the square root of 29.4. My total time is equal to t1 plus 2 lots of t2. So if I put that into a calculator, that gives me 1.75 seconds to 2 decimal places.